So if you look at what we just did, and that was the cool thing, if you look at comparing Nathan's to that one that Davmai had that bigger cross-sectional area right here. So even though they were made out of that same material, that one that had that bigger cross-sectional area, the lengths were the same, if you assume the resistivity was the same, then as that cross-sectional area was bigger, it had less resistance and it didn't get as warm. Whereas that smaller lead had a much smaller cross-sectional area, same value of resistivity, you had a much higher resistance. That really made the Chihuahuas angry to the point that they were emitting yips in the visible light spectrum and we could see it. Okay. Now, when you look at this mathematically, if you were to treat that pencil lead as a cylinder, does anybody remember how you calculate the volume of
Pi r squared times height.
Well, cross-sectional area times.
Oh wait, that's fine.
That's what.
Oh,
Yeah, that's
right.
Oh, hooray!
So it would be cross-sectional area times or the length, right? That would be the volume because you would have meters squared times meters, and you would get meters cubed. Okay, so we're doing a little trick here. A little trick.
Oh boy.
What? Oh, I thought somebody said.
Oh, we did
So,
guessing out there.
volume equals cross-sectional area times length, right?
Yeah.
So if I solve for area, what do you get?
V over L.
So I can sit here and go, okay, resistance then is
Oh, we're doing
resistivity.
Oh, boo.
And then if I solve for area, I get V over
L.
L.
Wait. And then you
Cancel out L's.
and then you
Wait a minute.
Now, do the L's cancel out?
No.
Or do I get L squared?
Squared.
Oh, I get L squared over V. So if you're comparing, here's an interesting thing. If you're comparing two wires that have the same volume, and this is going to be important. So you might have like a thicker wire that's shorter
Oh, so you can just cancel out the-
versus a smaller wire that has a greater length. So if these both have the same volume, what's going to, if you double the length, the resistance is going to go up by a factor of 4. Right? So this is where you have to play the game of what are you holding constant and what are you changing. Okay? All right. I think that's it. Don't forget, also, this is going to be important on one of your questions. And your book does it a little bit weird, but remember that voltage equals ED. Okay? All right? It has it as radius.
What are these?
But what are the units for that's your electric field, which are, one way you can do that is joules per coulomb. And then you've got, or you can also do that, let's do that as volts per meter. All right. And then if you multiply that by meters, the meters cancel out and you get volts. You're going to need that as a quick refresher on one of your questions that you have to do on the assignment. Okay? So just remember that voltage equals N. Okay? All right. I'm done. That was a quick deal.
What's the sound?
What? I'll sign it.
Always skips the N. Always misses the N.
1, 2,
Yeah.
2.
Asig.
Nice
Asig.
13.
Asig. Yeah.
Oh, we got some good last year.
What kind of problem is that?
4.
He struggles with it. Spelling is perfect. I think it's just a question.
No, no. So we're. Oh,
Hi,
that's
Shad.
right.
Hi, Shad. Hi, Shad.
No, then you've
Hi,
got,
Shad.
you got, you got magnitudes.
I got it.
Oh, nucleus.
Oh,
Oh, so it's 331.
Usually,
So
Maybe he didn't want to say hi. That's it, right, Bert?
Those are
Yeah, that's it.
That's always your go-to.
David. David.
Dale.
¿Quieres ir al festival?
David?
No.
No, aún like, lo quiero ver.
Label and
This will make sense when you get to 29. You need to draw a graph of two different wires. Label which one is which. Do not just randomly draw lines and think, I'm going to know which one is which. It will make sense when you get to that.
Graph and like.
When you get to this first question on number 9, it's going to be talking about a battery. We're going off of the conventional system where it's the Ben Franklin, where it's the positive charges. So when you get to question number 9, it's that very first one. Here's the battery, there's your positive terminal, and we're assuming that it's positive charges leaving from that positive terminal and going around. Okay? All right.